Okay, Assalamu alaikum and good afternoon, everyone. Thank you for coming here to this presentation. Uh, uh, my name is Dr. Asad Ali Zadi, and today I'm going to present a very crucial topic, and the topic is related to the Saudi Vision: how to link renewable energy outcomes with Saudi Vision 2030. And in this presentation, we are particularly going to focus on green hydrogen. So this is a pathway to a sustainable future, and I'll show you in this presentation how this is connected with the sustainable future, not only for Saudi Arabia, but also for the world as well. Before we go into the detailing of this presentation, let me introduce myself briefly. I hold a PhD in power and energy engineering with this specialization on biohydrogen production. So I have good experience in producing green hydrogen, and that is why I'm delivering this topic so that I can spread the knowledge about green hydrogen. And I'm also working as Associate Professor of Mechanical Engineering at Islamic University of Medina for the past 1 year. Overall, I have more than 10 years of experience in academia and almost more than 4 years experience in industry. Now let me give you an overview of today's presentation. So first we will discuss the Saudi Vision 2030 and how it aims to reduce dependence on oil and its transition towards a more sustainable energy future. After that, I will explain why green hydrogen is being recognized as a key solution for energy transition. Of course, we have other renewables just like solar and wind, but green hydrogen or hydrogen has something which is distinctive. We will see in this presentation how. We will then talk about this uh, like policies, major hydrogen projects which are going inside the kingdom and in the world. I will also talk about the future developments in this field. And by the end of this presentation, I'm hoping that you are going to have a clear understanding of Saudi Arabia's strategy in becoming a global leader in hydrogen energy and its production. Now, moving on with the background of this whole scenario. So, to understand the importance of green hydrogen, we must first recognize the challenges. What are the challenges? There are many challenges which are posed by the industrialization as well as the climate change. As we all know that fossil fuels consumption has led to increased carbon emissions globally, and it resulted in the global warming. We all know these facts. We know these facts in the news. We know these facts in every social media and all. There's a lot of promotion about climate, how to save the climate. So energy security is also a big issue. So what the world is doing, world is now transitioning towards greener energy sources, just like renewables. If we talk about hydrogen, particularly if we talk about the green hydrogen, then green hydrogen plays a vital and the crucial role in reducing carbon footprint while maintaining the growing industrial demands, because the industry needs energy, and the energy through fossil fuels is not so good for the environment, for the global warming, causing the global warming. So you must focus on the alternate sources. So here you can see that by 2050 hydrogen is projected to account for up to 18% of total energy production globally. So people and the world, including Saudi Arabia, they are now moving towards hydrogen production and using it to fulfill their industrial demands, industrial revolution and other things. However, currently 93% of the hydrogen is still produced from fossil fuels, which presents some major challenge. So hydrogen is being produced not only in KSA but also in the world. But the major source of hydrogen through which it is being produced is still based on the fossil fuel system, and that is why my presentation is focusing on the green hydrogen, how the green hydrogen is produced, how it can be utilized, how it can be stored, how it can be transported. This all information you will find in this presentation. Moving on to uh, the consumption pattern of Saudi Arabia. So here in this figure, you can see that there is a trend of energy consumption in Saudi Arabia, and for the time period of 1990 to 2021. The steady rise, you can see there is a steady rise, and this steady rise reflects the economic growth. The kingdom has done a lot of economic growth, industrial expansion, and increasing energy demands, as well as you can see from residential and the commercial sectors. So to sustain this growth while reducing carbon emissions, Saudi Arabia is actively looking at alternative energy sources, and hydrogen is a key player, can become a key player in fulfilling all these resources. Now we must know what are the key drivers behind the increase in kingdom's energy consumption. There are several factors here. You can see because of the economic growth. So economic growth require an amount of energy, and the energy consumption is increased. Population growth, which is constantly increasing, it is also contributing to the increased energy consumption of the kingdom. So economic and population growth naturally led to higher energy consumption. Subsidized energy prices in the kingdom, they are also like one of the reason behind more energy consumption. Rapid urbanization, and they are further contribute. Additionally, some climate factors, particularly higher temperatures, they lead to increased cooling and electricity consumption. As you can see in KSA, in the summer season, we have lot of energy consumption in order to, when we use air conditioning systems, centralized systems and all. So as well as you can see that the transportation sector and government initiatives to expand infrastructure also plays a crucial role in these increased energy consumption. So given these factors, yes.
I am in the sector of transportation.
Yeah.
Like to see transportation.
Okay.
Next time you put it at the top.
Okay. I will shift it to the top. Don't worry. But maybe next time I will bring another aspect of green hydrogen. Thank you.
Sorry.
Oh, no problem. So given these factors, it is clear that Saudi Arabia needs long-term sustainable energy strategy, which brings us to hydrogen. And that is the purpose of today's presentation. Since some of the undergraduate students, my students, are sitting in this presentation, so I'm starting with the basics. So here you can see the basics. I'm just giving you the revision. What is hydrogen? You already have studied that in chemistry, the intermediate chemistry and all. So hydrogen, what is hydrogen? Hydrogen is the lightest and most abundant element in the universe. And these are the definitions you have covered previously, that it is colorless, odorless, highly flammable and all. It is found in water, fossil fuels and biomass, but rarely in its pure form. And that is one of the reason you find hydrogen standing separately in the periodic table, because you cannot find it alone. We can produce hydrogen through various methods. This we will cover in this presentation, inshallah, including including electrolysis, where water is split into hydrogen and oxygen using the electrical power. Hydrogen is widely used in many industries, and the industrial revolution or industry 4.0 required hydrogen for its further sustainability and growth. Okay, so let's move on to why this hydrogen is so important. Walaikum salam. Now, why is hydrogen considered so important? So first and the foremost thing is that it is a clean energy source that does not produce carbon emissions. That is the first and foremost reason and the importance for the carbon. It also plays a crucial role in energy storage. Excess energy from renewables can be stored in hydrogen for later use. Hydrogen helps in decarbonizing industry that are difficult to electrify. And here you can find many applications. So let me give you some brief. Here you can see the blue arrows, and here you can see that wind energy, solar energy, and other renewable sources, they can be used to produce electricity, and that electricity which is being produced can be used for producing the hydrogen through electrolysis process, and this is called as power to hydrogen. You can also produce hydrogen to power, like use the hydrogen to get the power by using fuel cells. For this technology, we have microbial fuel cells, and based on the hydrogen, we have hydrogen turbines and hydrogen combined heat and power cycles through which we can also produce electricity. So this is a two-way process. We can have the fuel-based production of hydrogen. This I will tell you how the hydrogen is being produced by using methane reforming, coal gasification, biomass gasification, and many other methods in which we are basically focusing on the fossil fuels, and by using the fossil fuels, we are making the hydrogen. But what is the benefit if I'm using the fossil fuel to make the hydrogen and then use that hydrogen to make the electricity? That is the point and the challenging task in this whole scenario, and we need to cover it. And here you can see that we can have the storage for the pressure vessels, and the gas grids can be used, and it can be used in the commercial buildings and residential buildings. Hydrogen can be used in the transport sector. You must have heard about the hydrogen based cars, and there are many videos you can find on YouTube, debatable videos in which people are comparing the Tesla car with the hydrogen based fuel cell car, and they are comparing which one is better and why it is better, what will be the future of these technologies, whether the world is going to shift to the hydrogen completely or these electric cars will have. So I have some information about it in my presentation. We can also do the synthesis of the fuels, like by using the hydrogen, we can produce methanol, we can produce ammonia, which is a hydrogen carrier. We can have some hydrocarbons, which can further be used for various applications such as shipping, aviation, and we can use it in industry for refining and the steel production. So, as we have seen that hydrogen is very important for the economy and the industrial growth and all, but the point is, if I'm producing the hydrogen by using the fossil fuels, then it is of no use. And that is why my presentation is going to focus on the production of renewable or green hydrogen. And here we can see the comparison between Tesla and the hydrogen cars. So if somehow I have hydrogen, I can make the hydrogen based fuel cell car. And here I just compared the two technologies. Just like for if we talk about the Tesla, it's based on the lithium ion batteries. It has very good efficiency, almost from 85 to 90%, and it has with a good range of 400 600 kilometers. But its recharging time is too much. Like if I run a car and then I need to recharge, it takes a lot of time to recharge the batteries. It is lower cost because the technology innovation is going on, and the battery mining issue is the main issue. Like when we do the life cycle assessment of the electric vehicles, we come to know that the batteries and the disposal of the battery is the major concern. How can we dispose it of? This is the major concern to the researchers nowadays. If we talk about the hydrogen based fuel cells can be used for the hydrogen production. It has low efficiency, and because of its low efficiency, people are working. This is one of the open area for research, that you should perform some research to improve the efficiency of hydrogen based fuel cells. It has good range, and it has low refueling hours, but it is expensive. So what we need to do, we need to focus on producing the hydrogen with more innovative ways through which we can produce low cost or cheap hydrogen, and it is completely green. There are no things to dispose of when you are dealing with the hydrogen. Now moving on with the spectrum of hydrogen. So when we talk about the hydrogen color spectrum, there are many different types of hydrogen which can be produced. So here you can see the spectrum contains brown, gray, blue, turquoise, and green. There are some other color patterns for the production of hydrogen as well, and those colors are based on um, no. Okay, so So here you can see the hydrogen spectrum. The hydrogen spectrum contains different colors, and these colors are being designated based on the way it is being produced. So here you can see that the brown hydrogen is, we call, when it is produced from coal. So when we do the gasification of the coal and produce hydrogen, it is called as brown hydrogen. Of course, I'm getting the hydrogen having the higher calorific value and all other properties, but it is being produced with high greenhouse gas emissions, which is not good for the environment and a threat to the global warming. Now, second thing is the second pattern is the gray hydrogen, which is being produced by using the natural gas. Considering Saudi Arabia rich in the fossil fuels, most of the hydrogen which is being produced in the kingdom is based on the gray and blue hydrogen, which is being produced. And by using the natural gas, they do steam reforming. They treat natural gas with steam, and they produce hydrogen. But the gray hydrogen, it also has high greenhouse gas emissions. Similarly, for the blue hydrogen has the same technology as gray hydrogen, except it has an additional technology which is called as carbon capture and storage. So if we place carbon capture and storage system along with the steam reforming, it becomes the blue hydrogen. The hydrogen which is being produced is now the blue. The turquoise is being produced by the pyrolysis process. So when we do the pyrolysis, the outcome or the waste which is being produced is the coal, and the coal dust can further be used in some of the construction applications and all, but still it is producing the high emissions. We come to the end where we use renewables. When we use renewables, it becomes green hydrogen. And in the market, if we talk about the hydrogen energy market, then in hydrogen energy market, if you want to purchase the hydrogen, there are 3-4 types of the hydrogen which are commercially available. One is the blue hydrogen, turquoise hydrogen, gray hydrogen, and green hydrogen. So green hydrogen and all these hydrogens are being produced, and they have been transported, and they are being used for the industry. So when we are using the renewable energy, just like solar and wind energy for the production of hydrogen, we have the green hydrogen. Now I'm going to give you a brief overview about how different techniques are being used for the hydrogen production. Yes.
Sorry to bother you, but
Yes.
maybe I missed it.
Yes.
I mean, hydrogen is hydrogen. So
Hydrogen
how
is
do you
hydrogen.
differentiate
It is being differentiated based on the emissions it is being produced and the way it is being produced. So if it is producing high emissions and by using the most basic method of gasification, which was the common method, then it is called as the brown hydrogen. So this spectrum is being not based on the color of the hydrogen, because hydrogen is a colorless gas. But this spectrum has been designated based on the application and the way it is being produced.
is that is emission during the production of
Yes.
hydrogen or
Yes.
during the use
No,
of
no.
hydrogen?
During the production, when you are using the hydrogen, it produces no emission. It is 100% clean. And that is why I compared the hydrogen-based fuel cell car with the electric car, because it has no emissions, zero emissions. So production includes emissions, and for these productions, we have these emissions. Based on this, it is classified. The only waste is water, and water is still a requirement when you use hydrogen. So this is something which is really good about hydrogen-based fuel cell cars. Now let me tell you how brown hydrogen is produced. It is being produced by coal gasification. As I told you that when you have the gasification and the coal reacts with the water vapor to generate hydrogen and carbon dioxide. And this method is highly carbon intensive, resulting significant carbon dioxide emissions. This is the method to produce the gray hydrogen. It is produced through steam methane reforming, in which we have natural gas, and we get it reacted with the steam. And I've not included chemical reactions. If you are interested, you can Google it or watch some videos. But it also produces a huge amount of CO2, and that is the problem. So in other type of hydrogen, just like the blue hydrogen, there is an additional thing which is called as the carbon capture and storage system. So we just place a carbon capture and storage system, and we get the blue hydrogen. The next one is the turquoise hydrogen. It uses the pyrolysis process, and which produce hydrogen and solid carbon instead of CO2 emissions. So this method has potential environmental benefits, as the solid carbon byproducts can be used in industries such as for construction and manufacturing. So these are some of the applications, like we do the pyrolysis but we reuse the waste. Now moving on to the point of concern. The point of concern is the green hydrogen production. So this is the first method in which we do the electrolysis.